Okay, Taylor, I hope this is working. I don't know what was going on there. I could hear you sporadically, so I'm not sure. I set up that meeting a little differently than I've set up the other Zoom links before, so maybe it's operator error on my end. But let me walk through one of these equations and see if it helps you a little bit more. And then maybe try one of the ones that I sent to you from the exam that was not correct. See if you can figure out what you did wrong. Maybe we'll try it that way, okay? So if I've got, we're going to go with barium bromide, which is aqueous. And we're going to add to it sodium sulfate, which is also aqueous, right? This is going to yield barium sulfate, which is a solid, plus sodium bromide, which is aqueous. Okay, and I'll let you figure out if you want to go through and balance that. That's what it is. Okay. So what you want to do, that is called the molecular equation. Okay, so this is molecular. Okay. We want to get an ionic equation and then a net ionic equation. So the ionic equation means that we're going to split apart everything that is aqueous into its ions with charges. And if there's a coefficient, that has to stay with it also. So in this equation, the only thing we are not splitting apart is, there goes my camera, hold on. Hold on, my camera just paused. Come on back. All right, it's back. Hopefully you didn't get a big lag on that one. Okay, so the only one we're not breaking apart is the barium sulfate because it's a solid. It forms a precipitate. Okay, so we're going to look at breaking apart everything else into the ionic equation, and then we'll take it down one more step. So let's look at barium. Barium has a 2+ charge, and it's aqueous. Okay. Bromine has a 2 that has a minus charge, and it's aqueous. And I forgot, I have to put the 2 in there too. There's 2 bromines, okay? So that could be maybe where some of the confusion is. Take your subscripts and add them in, and if there's coefficients, you have to include them. So there's our barium bromide broken apart. Plus, we've got sodium that has a plus charge. There's 2 of them. And that's also aqueous. Plus, sulfate has a 2- charge. That's aqueous. Yields, over here we have barium sulfate. We are leaving that together. Do not take that apart because it's a solid. Okay, and then we're left with, and I'm going to run out of paper again. I do this all the time, but we've got the sodium and the bromine that we have to break apart. So we have 2 of the sodium, which has a plus charge and is aqueous, plus 2 bromine, which has a minus charge, and that's aqueous. Okay, so we're all broken apart, okay? Everything except for our solid. And I'm gonna give you a side note here too. If you had a liquid, so if you had water or if you had a gas, you would leave those intact also. But for what we're doing here, you're leaving the solid. Just look at breaking apart things that are aqueous, okay? We wanna look at what the solid is. So I'm gonna put down the reaction arrow, and we have barium sulfate. We wanna know what ions here contributed to making that barium sulfate. So let's look at barium. Barium is in the answer. There's a lag on my video, this is funny to me. So barium, the Ba2+ aqueous, is included in the net ionic equation. Let's look at bromine. Bromine's not in the answer. That one does not, that's a spectator ion. Is sodium in the answer? Nope, that's a spectator ion also. Sulfate, yes, sulfate is in there. So we put down the sulfate, okay? And then we have the sodium and the bromine on the other side. We know those are not included. This is called the net ionic equation. On your, on OWL, you'll see it written as NIE sometimes. Okay, so that's how you're going to do that with the net ionic equation. Go ahead and do a couple of the ones that, or at least one of the ones on the homework where I sent you the screen capture, and start with the original equation. Write it out and take a picture and send it back to me. Let's see if you can figure it out based on what I just did here, okay?